Okay, now I want to teach you about completing the square. My assumption is that you already know how to complete the square from the other maths that you were doing earlier in the year, and hopefully you're pretty confident with that. The way that I do it might be slightly different to the way that you do it, but hopefully you can get the right answer anyway. The only difference today that I'm going to show you is when a is bigger than 1. Just like when we're doing up here with our factorising quadratics using the cross method or the Miss Hayden's method, a, b and c. This time again a is going to be bigger than 1. Okay, so I've got a couple of examples for that, and they get a little bit messy towards the end, but hopefully you can stay with me and watch them and learn from them. So I'm just going to start with 2x squared plus 8x minus 6. We cannot complete the square unless the number in front of x squared is a 1. If it's not a 1, you just cannot complete the square on this one. So what I'm going to do is I'm going to take out a common factor of 2. Hopefully I would have seen that anyway, 2x squared plus 8x minus 6. Hopefully I would have seen that 2 can actually be a common factor, but it's not always as simple as this, and I'll show you a little bit later on. But I get this coming up, and now I'm going to complete the square on that. I'm going to leave my 2 out the front here, and I'm going to get x squared plus 4x. Now I need to get half of this term here, which is, I'm going to add half of that term in, so positive 4 on 2 squared minus positive 4 on 2 squared. This is the assumption that I'm making, that you already understand how to do this a little bit. At least it's jogging some memories. If you don't understand, please ask me. I'll come around and help you out. So I'm not really teaching you how to complete the square. I'm just kind of refreshing your memory a little bit here. So this becomes 2. Now x squared plus 4x plus 4 over 2, which is really the same as 2. I'll just put that there just so I don't need to write another line. That condenses down into x plus 2 all squared. Those 3 terms there condense down into x plus 2 all squared. Hopefully you know how to do that already. Now I've still got this bit at the back here. So I've got minus 2 squared, which I'll just put this here just so you can see it, minus 3, and there's a big bracket there. So this becomes 2 big bracket x plus 2 all squared minus, that's 4 minus 3, which is minus 7. That becomes 2 big bracket x plus 2 squared minus 7. And now I can do the difference of 2 squares between those two. So it becomes 2x plus 2 plus root 7, x plus 2 minus root 7. And there you have it. I've completed the square. Hopefully, I think the one mistake that you guys might make is you don't follow this 2 all the way down. You must have that 2 there. Hopefully you've seen that and you can understand that. You might have a slightly different way of working that out, but hopefully you still get to the same answer in the end. Okay, the second example I'm going to show you is a little bit trickier, but still not impossible. So the second one will be 3x squared plus 6x plus 5. As you can see with this one, there is actually no common factor. But I still can't complete the square unless the number in front of x squared is 1. So I'm going to take out the common factor, even if it's not common. Sort of like common sense. The trouble with common sense is that it's nowhere near common enough. That is 2x plus, now this, instead of being 5, is going to be 5 divided by 3. Okay, if I've divided everything by 3, I also have to divide the 5 by 3 as well. Now I can complete the square. 3 stays at the front, and I get x squared plus 2x plus half of that term there. So 2 divided by 2 squared minus 2 divided by 2 squared plus 5 over 3. Okay, all of these terms at the back here are still are inside that big bracket. So now that becomes 3 these three terms here, 2 over 2 is 1. Okay, these three terms here crunch down into this x plus whatever that one is there, 1 squared, minus 1 squared, which is 1 plus 5 over 3. Okay, now I'm just going to add those two things together there. So 3x plus 1 squared. Now, if I want to add those two things there, they both have to have the same denominator. And I know that 1 is the same as 1 over 1. So if I want to turn the bottom, the denominator into the same as that denominator there, I need to multiply it by 3, which means I also need to multiply the top by 3. So this becomes minus 3 over 3 plus 5 over 3. Okay, and I get 3x plus 1 squared plus 2 over 3. Now, unlike my previous example, where I had the minus 7, I could do the difference of two squares, because there was that's a square, and I treated that as a square, and there was a minus in between them. I could do the difference of two squares. In this case, I have, that can be a square, yeah, that is a square, and this can be a square, but I've got an addition of two squares. There is no rule for the addition of two squares. So I can't do anything more than that. The only thing that I potentially might do, just to tidy it up a little bit, is that I can multiply the 3 back into the bracket. So it becomes 3x plus 1 squared plus 2, because the 3 is multiplied by the 2 on 3. Now some of you might recognize this kind of expression. That is in turning point form, if we were going to sketch the quadratic. Now some of you have seen that in the normal maths you've been doing, core maths. Some of you have seen that, some of you haven't. But that's the turning point form just there. We've kind of looked at that in advanced maths as well, so hopefully you recognize it from there. Okay, I'm going to show you one more example of completing the square. Okay, this next one can get a little bit ugly, but it's not too bad. Hopefully you can use the method of staring at it for a really long time and understand it by the end of it. 2x squared minus 3x minus 4. Now incidentally, we always try and use the cross method or the Mr. Aiton's method or some other method before we try the completing the square. Completing the square is usually our last resort. It can be helpful, and if it's going to work, we can use the completing the square, but it usually does take a lot longer than any other method. So you try those methods first. I think I've tried that on these ones, it doesn't work, so now I'm going to do completing the square. Now again, I have to remove that 2. I have to take that out as a common factor. And here's where things get just a little bit messy. That becomes 3 over 2x minus 2. I would encourage you to leave it as 3 over 2. Don't turn it into 1.5, because you can move forward with 3 over 2, but 1.5 becomes a little bit trickier if you don't have your calculator. So this becomes 2x squared minus 3 over 2x plus, here's where it gets a bit messy, negative 3 over 2 divided by 2, because always half that term squared. Plus, I'll tidy that up in just a second. I just wanted to write that down. Again, negative 3 over 2 divided by 2 squared minus 2. Okay, now in a different color over here, let's just have a look at negative 3 over 2 divided by 2. That's essentially what it's trying to say. Now I know that 2 is really 2 over 1. Now if I go back into year 7 and I do these fractions, negative 3 over 2, whenever I divide by a fraction, I can flip it and multiply. So the answer becomes negative 3 over 4. Or 3 over 2, negative 3 over 2, which is the same as negative 1.5, divided by 2, which is the same as negative 3/4. Okay, so I'm going to write that down all here. That becomes 2x squared minus 3 over 2x plus 3 over 4, oh it's negative, 3 over 4 squared minus, whoa, made a mistake there, sorry, that should be a minus. That one's a plus, that one's always a minus. Negative 3 over 4 squared minus 2. Okay, and now I can condense those first three terms into a perfect square. That becomes x. This one is minus 3 over 4 squared. Generally, if that's a minus, in fact always, if that's a minus, that's a minus. If that's a plus, that's a plus. Okay, but it's good to go through the whole working out just to prove that anyway. So I've got this now. Minus, when I square these things, negative 3 squared is 9 and 4 squared is 16. Some people forget to square the 4 down the bottom as well, but you have to do that. Minus 2 all in a big bracket. This becomes 2x minus 3 on 4 squared. Now again, I'm going to get these under a common denominator. 2 is the same as 2 over 1. If I want to make the denominator 16, I have to multiply by 16, which means I have to multiply the top by 16 as well. So I get minus 9 over 16 minus 32 over 16. A little bit messy, but not too bad. This becomes 2x minus 3 over 4 squared minus 9 minus 32 is negative 41 over 16. Okay, now I've got a squared here. I can treat this as a squared and I've got a minus in between, so I can do the difference of two squares. That becomes 2, hopefully I haven't done too many steps in one go, 3 over 4 plus the square root of 41 over 16, x minus 3 over 4 minus the square root of 41 over 16. Now, I'm going to show you something else which you might have seen before, but that if you've got a square root of 41 over 16, the square root of 16 is actually 4, so I can turn that one into 2x minus 3 over 4 plus the square root of 41, because that's still there, but over 4 now instead of over 16, because I've done the square root of 16, and that becomes x minus 3 over 4 minus the square root of 41 over 4. Okay, so there we go. That's one that's a little bit uglier, but still we can complete the square on that one. Now the only other thing I want to say about all of this that we've learnt today is that these skills that we're learning can actually help us to do some graphing, because what we've done is we've factorized to get factors. Completing the square, these things are now factorized with the cross method and Straightens method. These things are now factorized. What we could do is we could now write a equals 0 on the back of all of these and find out what in this case m is. In this case, that's also m, the same question. We could find out what x is if we did equals 0. Once we've done that, then we know that we can get the x solutions, they are the x intercepts, and we can sketch the graph. We might do a little bit of those later, but for now, what we've done today is we've completed the square to factorize, we've used the cross method to factorize, or Miss Straightens method to factorize when the coefficient is bigger than 1.